this equation involves n number of multiplication because limit of n was 0 to n minus 1. We discussed it already, right? So x of n into e raised to minus j omega, there n multiplication for n calculation. So n into n square multiplications, and n minus 1 additions. N terms on you will have only n minus 1 plus terms. So n minus 1 additions for each computation. Likewise, for n computation, you will have n into n minus 1 additions. That's what we have discussed. Coming to f of t, we plainly set the equations, right? Now let's try to understand how you got that equations. So this was the butterfly that we used for dit. So say a, b, this is w and k. This was a plus b into w and k, and this is a minus b into w and k. So how many complex multiplication is involved in a single butterfly? Where can you see a multiplication over here? This thing, b into w and k. This is a multiplication, right? So there is only one multiplication over here. This is just repetition. When you perform b into w and k, you can save that in a memory and you can use that again. So how many complex multiplication is involved in this? Just one. In a single butterfly, you have only one complex multiplication, isn't it? So my question is, in solving an endpoint f of t, how many butterflies are involved? So let's find, we approached the problem by dividing it into stage. So how many stages were there? Total number of stages? Capital M. That was log
2 to the base n.
N to the base 2, right? That was log n to the base 2. So these are the total number of stages. Now my question is, I'm trying to calculate total how many butterflies are there, right? So how many stages are there? Log n to the base 2. Each stage consists of how many butterflies? One stage il etra butterfly aanulladu?
n by 2.
N by 2. That is n by 2. So each stage has n by 2 butterflies. N by 2 butterflies. There are total m stages or log n to the base 2. So total number of butterflies is, this is the total number of stages. Each stage has, sorry, this is log n to the base 2, right? Log n to the base 2. Then each stage has n by 2 butterflies. So this is the total number of butterflies involved, n by 2 log n, isn't it? So one butterfly has one multiplication. So into 1 is the total number of multiplication involved. So this is the total number of multiplication involved. Correct? Now just tell me what will be the total number of additions. So in a single butterfly, how many additions are there? This is subtraction, so you can treat it as addition of a negative number. So you have two additions involved. Two complex additions are involved in a single butterfly. So these are the total number of butterflies. Let me recollect the total number of butterflies again. N by 2 log n to the base 2. These are the total number of butterflies. You have to multiply with each butterfly has two additions. So total number of complex addition is 2 will get cancelled, n log n to the base 2. Hope you remember this equation. We have dictated it in the beginning of this session. The total number of complex multiplication is n by 2 log n. Total number of complex addition is n log n. Clarity that should be very clear. There can be problems related to this. Say how many multiplications or additions are involved in computing a 1024 point FFT and DFT. You have to make a comparison. Definitely here you will have more number of multiplication and addition. Here you will have less number of multiplication and addition as logarithm is involved. So this will be faster. That's why we say FFT is faster. Clear, Anna? You want any? Okay, right. Thank you. Then next thing is, I would like to add one more point. You call FFT as in-place computation. Can you just think and answer me why FFT is an in-place computation? I'm calling FFT as an in-place computation. Can you try to answer why that name particularly? In place computation. Anyone? കുറെയൊക്കെ നിങ്ങൾ ഒന്ന് ആലോചിച്ചൊക്കെ പറയാൻ പറ്റണം. എല്ലാ കാര്യങ്ങളും നമ്മൾ അങ്ങനെ പഠിപ്പിച്ചു പോകരുത്. In place. So this is something related to memory. That is the hint. Total memory used അങ്ങനെ നമുക്കൊരു advantage ഉണ്ട് ഇവിടെ in place computation ആയതുകൊണ്ട്. Anyone, can you make some guess? So you just consider a say 4-point DAT FFT. Okay, so the butterfly will look like this. So this is the butterfly. Okay, right. So this is how the butterfly looks like. So this is referred as in-place computation because for the first case, for the first stage, say you will have your inputs 1 0 1 0 something over here. So this will be saved in some memory locations. This is your input sequence. So say you need 4 memory locations to save this 4 bits. Okay. So just assume that that may be 8 bits. For example, just you can assume that you have 4 locations to save these numbers. You need 4 memory locations. So after the first stage, you will get some output, say ABCD. After the first stage, you will get some output ABCD. Now you can say that, do you want this 1 0 1 0 again to proceed to the next stage? അടുത്ത സ്റ്റേജിലേക്ക് ഈ കാൽക്കുലേഷൻസ് ചെയ്യാൻ വേണ്ടി ഡു യു വാണ്ട് ദിസ് 1 0 1 0 വാല്യൂസ്? ഇതിന്റെ ആവശ്യമുണ്ടോ? വേണ്ട. ഇറ്റ്സ് നോ ലോnger needed, right? So this can be replaced. This memory locations, these values can be replaced with the new values, say ABCD. Got it? Now moving to the next stage, say you get the output EFGH. Now assume that you have another stage over here. You had a third stage over here. So to proceed further to the third stage, we no longer need these ABCD values. So that you can replace those ABCD with what? The new outputs, that is EFGH. Got it? So the same memory location can be, you no longer want to use other memory locations. You can repeat or you can replace the current values with the output of the coming stage or that particular stage. അടുത്ത സ്റ്റേജിലേക്ക് പോകുമ്പോൾ തൊട്ട് മുമ്പിലത്തെ സ്റ്റേജിന്റെ ഔട്ട്പുട്ട് നമുക്ക് എന്ത് ചെയ്യാം? അവിടെ റീപ്ലേസ് ചെയ്ത് സേവ് ചെയ്യാം. So that's why it is referred as in-place computation. Clear ആയോ? Is that clear?
Yes, sir.
Okay. Yes, sir. Now let's move to decimation in frequency, DIF FFT. Okay, so make the next heading DIF FFT. Decimation in radix 2. Decimation in frequency, FFT algorithm. So how we started decimation in time algorithm? We started with the butterfly. We familiarized what the butterfly looks like, right? So here also, let's see how the butterfly will look like. There is a difference with the decimation in time butterfly. So hope you remember the decimation in time butterfly. Decimation in time butterfly, you had A over here and you had B over here, isn't it? And where will you mark W and K? Actually, that was in the lower arm, isn't it? But on W and K mark for DIT. For DIF, the primary difference is this is how you will represent your Tudel factor. That should be in this arm, upper arm. Got it? Now let's see what will be the output. DIT algorithm, I would like to recollect the outputs. This was A plus B into W and K, and this was A minus B into W and K, right? In DIF, this is simply A plus B alone, summation of the inputs, just A plus B. And the lower arm, you will have A minus B whole into W and K. So this is the butterfly of decimation in frequency. Just note it down. And we will look at the steps. Right? Hope it's clear. Now I would like to make a comparison between DIT. Always, it's I think you are comfortable with DIT, right? Decimation in time. Now let's see what happens with DIF. What is the difference in equations? So total number of stages, there is no difference. Capital M, total number of stages. That was log n to the base 2. Here also, you can say that that will be log n to the base 2. Next thing was separation between the arms. That was the important thing, right? Decimation in separation between arms. Separation between arms. In DIT, what was that? 2 raised to m minus 1. This is small m, that is the stage number. And here, the separation will be given by 2 raised to capital M minus small m. This is capital M and this is small m. Okay, make it a bit clear. This is capital M and this is small m. So either you can by heart the following equations, or I will tell you another easy method. I think you have already by hearted these equations, like 2 raised to m minus 1, right? So the idea is wherever you saw this thing, say 2 raised to m minus 1, this is the logic. Wherever you see m small m minus 1, that has to be replaced with capital M minus small m. Okay, wherever you see small m minus 1, replace it with capital M minus small m. Now let's formulate the equations. നമുക്ക് equations ഒന്ന് formulate ചെയ്യാം, right? Now what is the next equation you want to discuss about? എന്താണ് വേണ്ടത്? ഫ്ലോ ഡയഗ്രാം വരയ്ക്കണമെങ്കിൽ സെപ്പറേഷൻ കിട്ടിക്കഴിഞ്ഞു. Tell me. K യുടെ value. So how can you call K? K യുടെ എങ്ങനെയാണ് അഡ്രസ് ചെയ്യുക? That is അല്ല, K എന്താണ് വിളിക്കുന്നത്? K യുടെ പേരെന്താണ്?
Tidal factor exponent.
This is WNK is Tidal factor and this is the exponent term K. So that's called Tidal factor exponent. So the Tidal factor exponent, here the equation was nt by 2 raised to m, where t varies from 0, 1, 2, etc. up to 2 raised to m minus 1 minus 1. Now here the K Tidal factor exponent is given by, so help me to formulate the equation. Nt by 2 raised to small m. I have small m. If it was m minus 1, I will replace it with m minus m. So you have only m, right? So take minus 1 to the RHS. So what will it become? Capital M minus small m plus 1. Ready or no? This is the logic. You have to replace m minus 1 with capital M minus m. So 2 raised to m has to be replaced with m in a replace in the minus 1 in a RHS. So 2 raised to capital M minus small m plus 1. So this is the equation. Either you can by heart this, or if you are comfortable with this, just do the substitution. That's it. So this is how you can calculate K. Now tell me, T varies from 0, 1, etc. up to 2 raised to
Capital M minus 1.
M minus 1 can be replaced with capital M minus small m, then minus 1. So this is the last value. These are enough to do the problems, right? And you can say that general theory at you have to elaborate it. Total number of stages capital M is given by log n to the base 2. Then what you can say, each stage consists of n by 2 number of butterflies. Everything you say, each stage consists of total number of butterflies involved, or in a stage, that is n by 2. N by 2 butterflies, log n to the base 2, that much number of stages will be there. And separation between the arms is 2 raised to m minus 1. Tidal factor exponent is computed like this. And one more thing, very important, we'll make another comparison. This is 1, 2, 3, fourth one, very important. Here you can say that input is in natural order. Sorry, input is in bit reversed order, right? For DIT, your input was in bit reversed order, and what about your output? Output is in natural order. Serial, isn't it?
Yes, sir.
Okay. Here it is just the reverse. Here the input is in natural order. You have to write the input in natural order. You don't want to perform any bit reversal, but your output should be in, output will be available in bit reverse order. Output is in bit reversed order. And one more change will be there with the output. We will see that while doing the problems. There will be do some adjustments. We'll see that. Is that clear? Let's start. If so, let's try to solve one problem for an 8-point FFT. Okay, now.
Yes, sir.
Okay, so write the question. You find the FFT of. Find the FFT of. How many time is left? Class is up to 10 o'clock, right? 20 minutes are there. നിങ്ങൾക്ക് സ്പീഡിൽ ചെയ്യാൻ പറ്റുമോ അല്ലെങ്കിൽ നമുക്കൊരു 4 പോയിന്റിൽ ചെയ്യാം എന്ത് പറയുന്നു if you are comfortable I will try one 8-point FFT else I will start with an 4-point FFT
8-point മതി sir
8-point ചെയ്യാം right thank you so you write the question find the 8-point FFT of 8-point FFT of x of n equal to 1 2 3 4 1 2 3 4 4 3 2 1 so you have a sequence of length 8 right you have to find the 4-point DFT that's the question so I have drawn 8 lines 1 2 3 4 5 6 7 8 let me start so this is the sequence 1 2 3 4 4 3 2 1 the input is in natural order right that means first you have to write x of 0 or x of 1 x of 2 x of 3 likewise up to x of 7 so you can write the sequence in order that is the first advantage of this FFT bit reversal cheyanda so let me write that so 1 2 3 4 and 4 3 2 1 decimation in time aayirunengil what you have to do you have to go for bit reversal this is decimation frequency so this is enough നമ്മൾ ക്വസ്റ്റ്യനിൽ അത് കറക്റ്റ് ആയിട്ട് മെൻഷൻ ചെയ്യും കേട്ടോ ഐ തിങ്ക് ഐ ഹാവ് നോട്ട് കംപ്ലീറ്റഡ് ദ ക്വസ്റ്റ്യൻ ക്യാൻ ബി ലൈക്ക് ദിസ് ഫൈൻഡ് ദി 8-point FFT of the sequence x of n equal to 1 2 3 4 4 3 2 1 using radix 2 DIF FFT algorithm you add that point to the question using radix 2 DIF FFT algorithm okay don't start drawing butterflies just wait for my instructions കാര്യം ഒരു ചെറിയ കാര്യം പറയാനുണ്ട് hope you have marked the input sequence നമ്മൾ ഇതിൽ ചെയ്യേണ്ട കാര്യം നിങ്ങൾക്ക് ഇതിൽ കാണാം ഞാൻ previously already points in scale കൊണ്ട് മാർക്ക് ചെയ്തിട്ടുണ്ട് okay to get it aligned so this will be my first stage how many stages will be there to solve this problem definitely 3 stages 3 stages log 8 so that is 2 raised to 3 is 8 so previously in DIT algorithm, first stage we will draw with lesser space, and on going to the second, third, and stage you will increase the spacing. So like spacing kuti po. Why you did like that? Because the butterflies will get complex moving to the stages. Here the phenomenon is just reverse of that. In the initial stages, you will have overlapped butterflies. Got it? Coming to the next stage, they will get separated. And in the very last stage, you will have independent butterflies. Overlap cheyada independent aayittulla butterflies undav. So it will be apt to give maximum spacing for first stage. Second stage, you reduce the space. Third stage, minimum space is enough. So you have to plan it accordingly. So let me start with the first stage. So the reason will be very clear to you when you do the calculation for the separation between the arms and all. Okay. So let's do that calculation for different stages. So let's try with say stage 1. Okay, let's proceed with stage 1. You have 3 stages, right? So stage 1, stage 2, and stage 3, right? So the difference in the stage is you will have m equal to 1, small m equal to 2, and small m equal to 3. And remember, capital M is 3 in our case. Because 2 raised to 3 is 8. You are doing an 8-point FFT. So here the separation between the arms. Let's calculate that. So that what is the equation? 2 raised to m minus m. So this is equal to 2 raised to 3 minus 1. So 2 square, that is 4. Here the separation is 4. Let me do all the calculations. Now here the separation is 2 raised to m minus m. This is for the first problem. Let me write all these steps. 2 raised to 3 minus 2, this is 2 raised to 1, so this is 2. And here the separation for the third stage, that is the last stage, 2 raised to m minus m, that is equal to 2 raised to 3 minus 3, isn't it? So this will be 1. So you can see here the separation is large, and that means the butterflies will overlap. Here the separation is bit less, means they'll try to split up. And the last stage, the separation between the arm is only 1 unit, so the butterflies will be free from overlapping. Can I proceed?
Yes, sir.
ഓക്കെ. ഏതെങ്കിലും സ്റ്റെപ്പിൽ ആർക്കെങ്കിലും ക്ലാരിറ്റി വേണമെങ്കിൽ നിങ്ങൾ അന്നേരം ചോദിച്ചു പോവുക കേട്ടോ. ഞാനിതിപ്പോ സ്പീഡ് ആവുന്നുണ്ടോ? എനിവൺ ആർക്കെങ്കിലും അങ്ങനെ തോന്നുന്നുണ്ടെങ്കിൽ പറയുക കേട്ടോ. 9:48. Let it finish. So we'll see the first butterfly. So first stage, the butterfly should start with a separation of 4 units. Separation is 4. So let me start drawing the butterfly. Let me start from this point. So after 4 units, it has to end. So 1, 2, 3, 4. So it should end here. 1, 2, 3, 4. Right. So this is my first butterfly. Right. Let me draw the second butterfly. I can start drawing from this point because ഞാൻ ഇതുവരെ point use ചെയ്തിട്ടില്ല. So that should end after 4. That's the second butterfly. Then let me draw the third one. There's a third butterfly and fourth one. It will come like this. So these are the 4 butterflies that we have. So these are not butterflies, these are just eggs only, right? If it has to become butterfly, you have to mention the twiddle factor in the upper arms. Okay, we will calculate that. Let's try to complete all the butterflies and calculate the twiddle factor exponent. Can I move to the next stage? Stage 2, separation between the arm is just 2 units only. So let me start drawing the butterfly. So start from here, that has to end here because separation is 1, 2, just 2 units. Now next butterfly. To be very careful in drawing the butterflies, selecting the points. So where can I start the next butterfly? I cannot start anywhere of this point because already some butterflies are occupying those points and only free space is this thing. So I have gap over here. That means I'm repeating the blue color butterfly again, as we discussed in the last class. No 2 butterflies in a stage can share a common point. So that's it. And here I will mark the twiddle factor exponents. Sorry, twiddle factors, not twiddle factor exponent. You will mark the twiddle factor. Coming to the third stage, separation between the arm is just 1 unit only. So I will start from here and say this is my butterfly. And I cannot start from here because this point is already shared by this butterfly. So let me start from this point. So why I am using the same color? Because we are having some spacing, right? That means the butterfly will be of same characteristics. So you can mark the twiddle factor over here. We'll compute it at the last. So that's it. This is your butterfly diagram to compute an 8-point FFT. If we have completed, we will move to the calculations. I'll give you 1 minute to complete the drawings. Any doubts up to this? Complete ചെയ്തെങ്കിൽ ഒന്ന് റെസ്പോണ്ട് ചെയ്യുക. I will move to the calculations.
Sir, complete.
Okay. So അല്ലാത്തവർ തൽക്കാലം സ്റ്റോപ്പ് ചെയ്യുക. Then just focus on the calculations and continue. So the only thing is you have to calculate the Twiddle factor exponent, right? The Twiddle factor exponent was given by nt by 2 raised to m minus m plus 1, isn't it? So that is, in our case, for the first stage, this will be n is 8, right? So 8t by 2 raised to m minus 1. M is 3. Do it carefully. Minus stage is 1 plus 1. So this is 2 raised to 3 is 8. Minus 1 plus 1 cancel out. So 2 raised to 3 is 8. 8 will get cancelled, and that is t. So your k is equal to t. Now just find the values of t. T varies from 0, 1, 2, etc. up to 2 raised to m minus, previously it was m minus 1 minus 1. Now it is m minus m minus 1. So let's find this value. Let me do it for the first step. 2 raised to 3 minus 1 minus 1, right? That's the value. So 2 raised to 3 minus 1. So that is 2 raised to 2. 2 square 4. 4 minus 1 equal to 3. So this value will become 3. So that what is the value of t? 0, 1, 2, 3. 3 is the last value. Therefore, what is k? K is equal to t. Therefore, that is same as 0, 1, 2, 3. So you have 4 values for k. That is 0, 1, 2, and 3. That's why we have 4 colors for the butterflies in the first stage. Just remember the values 0, 1, 2, 3, right? 0, 1, 2, 3. Let's draw it over here. W8, 0, W8, 1, W8, 2, W8, 3. That is the 3 Twiddle factors. Can I move to next stage? Any doubts in this?
No, sir. Continue.
Okay. So next, do the calculations. Nt by 2 raised to m minus m plus 1. Just substitute the values. 8t by 2 raised to 3 minus 2 plus 1. 3 minus 2 is 1. 1 plus 1, 2. 2 square, 4. 4 and 8 will get cancelled. You will get it as 2t. Now find the value of t. T varies from 0, 1, etc. up to 2 raised to m minus m minus 1. So find this value. We'll do this directly. M equal to 3, small m equal to 2. 3 minus 2, you'll get it as 1. 2 raised to 1 is 2. 2 minus 1 is 1. That means you have only 2 values, 0, 1. Therefore, don't carelessly consider it as 0 and 1 directly for k. You have to find k equal to 2t. Always practice this. Even though k equal to t, just write this step. Okay. That will avoid mistakes. So 2t. T is 0 and 1. Therefore, k will be how much? 2t. 2t. Okay. So 0 and 2. When t equal to 0, k is 0. When t equal to 1, 2 into 1, this will be 2. That's why you have k equal to 0, 2. So these are the 2 values of k, 0, 2. So what will be this Twiddle factor? W8, 0. And this is W8, 2. That will repeat for the coming butterflies. W8, 0 and W8, 2. So second stage, we have given Twiddle factor for all the butterflies. So we will move to the third stage. Moving to the third stage, k equal to, again, just find the values. Nt by 2 raised to m minus m plus 1. So that is equal to 8t by 2 raised to 3 minus 3 plus 1. So this is 3 minus 3, 0 plus 1, 2. So this is 4t. Now t varies from, just find the value of t, 0, 1, etc. up to 2 raised to m minus m minus 1. And in our case, this value will be how much? Capital M is 3, small m is 3. 3 minus 3 is 0. 2 raised to 0 is 1. 1 minus 1 is 0. That means you have only one value. T is equal to 0. Therefore, what will be k? K is 4t. That will be 0. Your k is having only one value, right, for the third stage. So All the butterflies are of same color because k is having only one value, W80. This is W80. This is W80. This is W80. So we have only 2-3 minutes left for the class. Clarity then you do the computation yourself. Try to solve 1 or 2 butterflies. Can I start solving the butterflies? Solving the butterflies will give you the answer, right?
Yes, sir.
Okay. So let's start with the first butterfly. So this is 1 and this is 4. I'm focusing on the blue butterfly. So what is the upper arm? It's pretty easy. Just A plus B, right? Hope you remember the DIF butterfly. Upper arm is A plus B, lower arm is A minus B into W and K. So it's always better to calculate all the W and K values on one side of your answer sheet. Say W80, then W81, 2 and 3. You need all these 4 values. Okay. Hope we have done it in the last class, so you can directly copy those values. W80 was 1, W81 was, can you tell me those values?
One by root 2 minus
J
Under
1 by, okay.
1 by root 2 j.
W82 is minus J, right?
Minus
Okay. Then W83 is?
minus 1 by root 2 minus 1 by root 2 j.
Okay. Minus J 1 by root 2. That's it. So let's start solving the butterflies. So first blue butterfly, total factor is W80, that is 1. So upper arm is nothing, just always sum of the inputs. So that is, you can see this, right? 1 plus 4, right? You add these two numbers, 1 and 4. So that will be 5, right? And the lower output, this one is 1 minus 4, that is minus 3 into the total factor, A minus B into W and K, right? This 4, sorry, not this one, this 4. So 1 minus 4, that is minus 3 into W and K. W and K is W80, that is 1. So minus 3 into 1, this will be minus 3 and this will be 5. Now move to the next butterfly, that is this one, brown butterfly. So it's 2 and 3 are the inputs. So 2 plus 3, 5 will be the upper output, right? Now let's find the lower one that comes over here. So that will be 2 minus 3. What is 2 minus 3? Minus 1. A minus B ആണ് 2 minus 3 is minus 1. Butterfly this is the butterfly that you are going to solve. A, B, W and K. Here you will have A plus B and here you will get A minus B all into W and K. This is the thing that we are doing. So A minus B is 2 minus 3 is minus 1 into W and K. W and K is W81. So minus 1 into W81. This was W81 minus of that. So what you will get? Minus 1 by root 2 plus J 1 by root 2 will be the answer at this point. Now let's move to the next butterfly, that is this yellow one. So 3 plus 2, upper arm is very easy, just add the numbers, inputs. 3 plus 2, again 5, okay? Then there's another one, I'm just cancelling that. So 3 plus 2, that is 5. And for the lower arm, it is 3 minus 2. So that is 3 plus 2, 5, yeah, 3 minus 2, that is 1 into total factor. What is the total factor for this butterfly? W82. So 1 into W82, that is minus J. That's it. It's 10 o'clock. Those who want to take a break, you can leave. I will try to continue as much as possible. In 5 minutes, I will. This is video is being recorded, and I will share it to you. Break leave, no issues. You can refer later if interested. So this is minus J, and the last butterfly, the red one, 4 plus 1, upper arm will be 5, lower arm 4 minus 1, 3. 3 into W83. W83 is over here. So you have to multiply with 4 minus 1, 3. So this will be minus 3 by root 2 minus J 3 by root 2. Right? So you have the output for all the first stages. Now we will move to the second stage. So moving to the second stage, സ്പീഡ് ആവുന്നുണ്ടോ? ആർക്കെങ്കിലും ക്ലാരിറ്റി വേണമെങ്കിൽ ചോദിക്കുക. ഐ വിൽ വെയിറ്റ് ഫോർ 1 minute. You do the calculations. ഈ W1 ഉം 3 വരുന്ന ബട്ടർഫ്ലൈസേ ഉള്ളൂ ഇങ്ങനെ കോംപ്ലക്സ് ആവുന്നത്. നെക്സ്റ്റ് ദിസ് തിങ് ഈസ് ഈസി. W80യും W2യും വരുമ്പോൾ കുറച്ചുകൂടെ കാൽക്കുലേഷൻ എളുപ്പമായിരിക്കും. When you write in the notebook, as I said earlier, ഇവിടെ നിങ്ങൾക്ക് ഇതിങ്ങനെ എഴുതുന്നത് കൺഫ്യൂഷൻസ് ക്രിയേറ്റ് ചെയ്യുന്നുണ്ടെങ്കിൽ യു ക്രിയേറ്റ് എ സ്പേസിങ് ഓവർ ഹിയർ. ഇവിടെ ഒരു സ്പേസിങ് കൊടുത്ത് തന്നെ വേണം ചെയ്ത് നോക്കിക്കോളൂ. ദാറ്റ്സ് അപ് ടു യു. So let me proceed to next stage. So again here 5 plus 5 you will get 10, right? This output 5 minus 5, so that is 0 into Tedal factor, that will be 0. For this butterfly again 5 plus 5 you will get 10, then 5 minus 5 0 into Tedal factor, that will be 0. So that was easy, right? Coming to next blue butterfly, minus 3 plus minus 3 minus j. So this is minus 3 minus j. Upper arm is just a plus b. Lower arm is minus 3. Here you have to do a multiplication. I will write over here minus 3 a minus b. So plus j, minus 3 plus j into the Tedal factor. What is the Tedal factor? W80. So W80 is 1. So this is minus 3 plus j. Here you will have minus 3 plus j. Then next last butterfly, that will be a bit complex. See, you have to perform a plus b, right? But a plus b alle varandadu. So let me add the real parts. Minus 1 by root 2 minus 3 by root 2. So what will be that? Minus 4 by root 2, isn't it? So minus 4 by root 2. Here we'll have minus 4 by root 2. Then real parts, plus j 1 by root 2 and minus j 1 by root 2. So you have real part minus 2 by root 2, right? Minus j 2 by root 2. And similarly find the lower part also. Lower part you have to take the difference, then you have to multiply with minus j. So it's 10 5. To complete the calculations, I will just write the final answers. Final answers will be 20, because it's 10 plus 10, 20, then 10 minus 10, you will get 0. 0 plus 0, that will be 0. Then 0 minus 0, this will be 0. So 20, 0, 0, 0. So this is, you find the remaining terms also. This is your x of 0, isn't it? This is x of 1, x of 2, x of 3. അങ്ങനെയാണോ വരുന്നത്? Don't take like that. You have to do the bit reversal. Output, input natural order എഴുതിയപ്പോൾ output will be in the bit reversed fashion. So you have to find the bit reversed fashion. നമ്മൾ ഇന്നലെ ചെയ്തത് നമ്മുടെ കയ്യിലുണ്ടാവും. This is x of 0. This will be x of 8. Order എന്ന് പറയൂ. X of 4. X of 12. 12 അല്ലല്ലോ. തെറ്റിപ്പോയി 8 ടേംസേ വരത്തുള്ളൂ. ഇത് 8 തന്നെയാണോ ഒന്ന് ക്വാളിഫൈ ചെയ്യുക? 2 അല്ലേ? 2നെ തിരിക്കുമ്പോൾ 2 തന്നെ വരും. കയ്യിലുണ്ടോ? നോക്കി പറയാം. എനിവൺ?
X of 4.
First one is x of 0. Second one is x of 4.
X of 2.
X of 2.
X of 2, okay.
X of
6.
X of 6. And
X
here
of 1.
1. And x of
5.
5. X of 3. And x of 7. So your output will be in this order. So you have to write your x of k. Say x of k is equal to, first x of 0 will be there. X of 0 is 20 in our case. Then you have to look at what is x of 1. Then you have to look what is x of 2. X of 2 is 0. Okay. X of 3, you have to find that. You have to write the final answer in this particular order. Clear? Any doubts? അടുത്ത അവർ ആരാണ്?